One other important aspect probably is very important for you to know and understand. And what is important is that if you think about symmetry between git push and other command, symmetrical command is not git pull, but symmetrical command is git fetch. And git pull is actually far fetching command, which actually means git pull together with git merge. And what does it mean? Git push means synchronize branch of your local repository with branch of remote repository, and such synchronization work correctly if you do not try to push against the wrong commit on remote repository. And git fetch means synchronize branch of remote repository with your local repository. And again, if you do not try to fetch to some longer history than you have here in local repository, it also goes without any problems, even if you have potential conflicts for your content of the file. And one of approaches you can use, of course it may not work in long term, because in long term you may want to have your backups of previous well-known states where something worked on your project. But one of ideas is that you use git fetch instead of git pull, because git pull means git fetch together with git merge, and if you try to merge and if it have conflicts, then of course you will have conflicts. For example, let's go back to these test projects. And make some changes. Now it is LLL here for one user. For another user, so this other user has made many commits in particular file, and of course if these are other files you do not have any problems at all. For example, and particularly for this file, now version of this file is with this content, but this is something much older. But this user has not added any commit at all. So for this user, this official versions, official chain of events or chain of commits is much shorter than for this other user, because all the changes he or she has made, let's say also, let's know some differences here, are only on his workspace. So this user has these files, but these are not added into version history at all. And this user can just say git fetch. And because this user has not made any commits, even though for all of these files there may be potential conflicts, but because Git checks conflicting histories, not your workspace, what you have, you see here is some very old version and here is some very new version. He may add these files on top of last history for this here. For example, he may say git add also d, git add e, I think I added these files. Oh. And then he or she may add these changes on top of this official history. So Lifeline in this case looks like this. Workspace 1, workspace 2, some files here, and git version, commit, 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 commit. And that was also pushed to the mode repository. And when you fetch, you get this commit, 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 commit for these things, but because this user has not had any commits somewhere here in between, he or she always may apply from this workspace or files and folders as yet another commit without any conflicts at all, on top of this history he got from git fetch. So remember, if you, one of the things, and again here are two philosophies, how frequently you deal with merge conflicts, and if you are happy without making any local commits here, you do not commit anything at all, you just fetch and update your local Git database, and then you can always see differences and update it as yet another commit in between these many histories. So therefore, one of my recommendations is to remember that git merge actually means git fetch, git pull means git fetch and git merge, but if you don't add local commits in your local history of your project, you just fetch and then interesting. Oh, I think before this still need git merge. So you do git pull or git merge separately. That's what was missing here. So I decide what I need to merge here for D, Yeah, let's say no. Both changes together and for E here. And something like this. And then one of things you need to remember is that when you look on history of the project, there are two different approaches what you show on the remote repository. One approach is that your remote repository shows actual development, which usually is messy. So you see many branches and merges in this history with resolved conflicts, etc. So real life is messy for any non-trivial project. And problem for such project is that if you introduce some regression, there is nice command called git bisect. And what it does, for example, you know that somewhere in this commit it worked, and here it doesn't work. Then it can jump with divide by 2 and check out particular commits until it finds in which particular commit this regression was introduced. But if you have many several branches here, this jump here goes for particularly selected branch, and if you find out that it is introduced here and you have many parallel branches, you need to do this git bisect for all these parallel branches as well to understand where exactly. So bisect works much harder. And therefore for remote repositories there are some projects where everything is like this. How can you do this? There is command this git cherry pick particular commit, and you can always cherry pick particular commit from other branches and add it in top of your main development branch, master branch. And then official history looks like a precise sequence of commits one after another. So of course it doesn't look like this in reality. For example, on local repositories you have several parallel branches, but when you make it into master you do something like this. You first cherry pick these commits in sequence, then you cherry pick these commits in sequence, and then you cherry pick these commits in sequence. So you linearize everything what was parallel here as sequence, like sequential one branch, sequential another branch, sequential another branch. And of course it looks clean and nice, and git bisect works, but of course such history actually do not show actual history how it worked, and it requires additional work to do in such ways. So that's about other things. And then what is important to know is that when I told you about the synchronization of local repository and remote repository, you always synchronize one particular branch with remote repository and local repository. And it doesn't mean that you have so many local branches as in remote repository and vice versa. And again, in this practical example, I have a lot of local branches in my local repository for particular bug fixes or whatever, to test them out before confirming them. But if you look on remote repository of this project, where are branches? Here. You see that here are some branches on remote repository which I do not have on local repository. So I do not have this historical branch, I do not have Italian, and I do not have Android, but I have some other branches here. But what I'm synchronizing is only my master branch from local repository and master branch to remote repository. So remember that it is not required that you have all the same branches on remote repository as you have on your local repository. You may have more branches on local repository, but also remote repository may have some other branches which you do not have locally. So synchronization is not between entire Git repository, but synchronization is between branch on local repository and branch on remote repository. That may be important as well. And now I think we should analyze your practical exercise. So your practical exercise is following. You will need to merge different branches into your project. For this package activity 18, and backstory, if you need one, is something like this. There are some projects, and I think these are badly managed projects, where dealing with conflicts and merging different branches is up to one person, usually called buildmaster. And idea is following that each of developers have their own branch, and they develop these features in their branch, and then they synchronize his local branch to remote branch, and because they are only persons working on this branch, nobody of these developers needs to deal with conflicts, because they do not have any conflicts, because they are only ones who add some new commits on top of previous commits. And then project look like this, that you have like master branch, and then branch for developer 1, developer 2, etc. And then when some of developers claims that this feature is finished, then this build master just needs to merge this branch together. And as I say, that if your colleague says you just need to do this, just means two things. Either he or she can't do this by him or herself, or he or her spent many hours on this and still couldn't figure it out, or spend hours on this and do not want to do this anymore. So in general, that's what just usually means in reality. And so your task for this activity is just to merge these other branches created from other sources like other teammates or whatever into master branch, and you will see that there are conflicts. You will need to solve these conflicts as well. And if we look on our project, first thing is to check that everything till to this exercise is added to version control system, and you have nothing to commit walking tree clean, and also that your branch is up to date with origin master branch. So everything is committed, and all commits are also pushed to remote repository as well. How can you see this kind of information on graphical IDEs? I do not know. If you know, you will teach me. And we see that currently we have only master branch for our project, and we will need to add another repository entry to get content of this project, and then we will need to get this content for other branches as well, not only master branch. And as usual, you can do it in your graphical IDE. You need to add another entry to remote repository, but I think for documentation purposes, etc., it is much easier to do in terminal. Okay, so before that I can say git remote -v. So now I have only one remote repository. In some cases, fetching and pushing may be different URLs, and therefore these are two different ones, but URLs you can see is the same. And remember, actual symmetrical command for push is fetch, not pull. And so we add another repository entry to different remote repository, which we call upstream, and its URL is following. And because on this remote repository we have other branches as well, we will fetch the content from upstream repository branch 1 into local repository branch 1. And now I have my master branch and branch 1. And now I have my master branch, branch 1 and branch 2. And now if we compare it, we can do comparison tools. For example, we can say git diff tool for entire directory like master and branch 1. And diff tool should be written properly. And there are many differences, because on that remote branch nothing is implemented in these activities, but we can ignore them. What we cannot ignore is content of files for GTM activity 18. And when we compare it, we see that here is some content, and content here is essay from Eric Stephen Raymond, The Cathedral and Bazaar. And fortunately for us, all lines are numbered here, and we see that something is missing, for example, in this master branch regarding to branch 1, and we can compare them and add, for example, it in following way, and then we can example, save it. But problem here is that in this particular case, this diff tool, meld, actually it does only one thing. It compares files and folders. So that's what this tool can do. And if you, for example, open this to compare two different branches, so here, when I say open this git diff tool, which is configured meld for me, and compare master branch with branch 1, what is actually happening? Content of master branch is extracted in temporary folder. Content of branch 1 is extracted into temporary folder, and then this tool compares this temporary folder with that temporary folder, because this tool cannot deal with Git database directly. And therefore, if you do not know this and you try to make some changes here, see, when I save it, I actually will save it into file /tmp git-diff tool blah 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 here, not in my actual workspace. And that's a problem. And maybe I have not checked it. You can check it yourself with modern IDEs and compare branch to branch, and maybe you are allowed to save it into your workspace. But I will not be surprised if it will not work as you expect. And then there's also merge tool, but you cannot call merge tool in following way. You can just say merge it in here, but I will not do, because it will create quite a lot of mess to merge it, because these files have conflicts, and because we have conflicts not only for this folder of activity 18, but we have differences here for activity 03, 04, blah 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 blah. So these branches are quite different between each other, and blindly trying to merge it would be quite stupid thing to do. And what we can do about such things? My recommended approach, and remember that when I worked in software development projects, I do not work as a developer. In most of the time I have worked as a systems analyst, tester, build master, infrastructure oriented person, not as a developer. And I find out that the easiest way to deal with such thing is to use old school tools which can work independently of version control system you are using. So in theory you can do advanced git commands and merge particular parts in this folder for activity 18 and do it. But it is not required, because what is required is that you create correct merged content for these conflicting branches and commit it and push it to a remote repository. And this approach, which I will show you, I have used it first with CVS version control system, which you shouldn't use anymore because it's old and rigid. Then I use this approach for SVN version control system. Now I'm using it with Git version control system, and if some better version control system will come, I still will be able to use this approach, because this approach do not care about version control systems at all. And it only cares about old plain objects like files and folders. So now I have created my project with 3 branches, and I need to merge particular content of branch 1 and branch 2 into my master branch, and there are a lot of differences between master branch and these branches for other activities. I do not want to touch them, but I need to merge them, and I think the easiest way to do is following: that we forget about version control systems, either CVS, SVN or Git or Mercurial or whatever, but we do old school approach. We compare files and folders. So I can create a copy of this project, either in such way, or if you person oriented on graphical interface, Ctrl+C here, Ctrl+V here, and let's create another copy here. So now I have added some complexity in my infrastructure. Instead of 1 messy project, I now have 3 messy projects, so that's bad. But sometimes it pays off to create more mess if you can control it better. And I will do following. So here I will go to my copy of the project -1. Here I will go to my copy of master project, and here I will go to copy of U0-2. And your bash prompt is not customized here. You don't see what current branch is, but you can write git branch command in terminal to see what current branch is. And currently all these 2 other copies of this project are the same, but we can make them different by saying git checkout branch 1. And now I have checked branch 1 into project -1. And I have checked out branch 2 in copy of the project -2. And now they are different. Their files and folders are different, because when I check out branches, I extract files and folders into my workspace for this particular branch. And now these projects are not complete copies of them. They have complete copies inside Git database, but their workspace now is different. In this project U00, my files and folders represents what I have in my master branch. In UU-1 I have files and folders which are in branch 1 of Git database, and here for branch 2. And now I can use old school projects, old school tools to compare these files and folders without caring about Git version control system at all. So I open meld comparison tool, and I will use directory comparison. And in this particular case, in most of cases you will need to compare 2 different sources, like remote repository or coming from your 1 branch and master branch or whatever. But in this particular case we actually have 3 different branches, so we can enable 3-way comparison here. And here I will choose my project with branch 1. In the middle I will choose project with master branch, and here I will choose project with branch 2. And when you do three-way comparison, your target, which you want to actually compare, should be in the middle. You can make them in different order, but then of course comparison is harder because you need to jump over one source to another to compare them. And if you choose only two, then of course it's not much difference. Is your target in the left or the right? And then we compare these three different folders. And we can ignore. How can we collapse them? I don't remember. So sorry for interruption, and I hope that you use this time to catch up. So and now there are many differences between these two branches and my project, but of course we ignore almost everything except one place which we do not ignore, and that is content of the files for this activity 18. And when we compare it, you see here that now I am comparing real files which I can edit and save in real folders. So in difference when I used meld to compare branch to branch, and it was extracted in temporary folder. Of course I could copy content of this temporary folder in my workspace later, but I think it is not worth doing that. And so now I compare them and I can put these conflicting changes together. And if that text would be Java code, then of course you should understand Java code and compare blocks and methods and what inside methods here. But for these who may be a little bit tired of Java, here is plain text and we need to mostly compare line numbers here. And if we see that line numbers are increasing gradually without jumps, that's okay. If we see that here is jump, so that means we need to add missing content here. And I did this with just simple click here, but I can't it merge with simple click here, because then that tool will overwrite lines from 34 till to 58 with lines from 59 till to 72. So here unfortunately tool is a little bit confused and I need to do something like copy and paste. And as far as I can tell, probably I have collected all necessary content from these conflicting branches and my master branch in this project. So I can save it, and I will save it in real file, in real folder here, and I can continue with next files. Again, if this tool, suggestion for this tool is good, like replace this short content with that large content, you can just copy, click on this button there. If suggestion for this tool is not good, you have to be smarter than that tool. And as far as I can tell, this merged content looks good to me. And I continue with other files. So here, not only tool is confused, I am confused as well. Then, in this particular case, we just need to look on line numbers and check what is minimum line number, what is maximum, and how these blocks of text should follow each other. Probably here I can click this button because line 374, 375. This looks like a good addition to me. But here at the beginning, so line 200, blah blah blah. Maybe I have, something is missing here. So here I see last line is 535, but here is 536. So I can add this content at the end of this block as well. And I'm not absolutely sure about this, but as far as I can tell, with Quick View, probably I have collected all these conflicting blocks of text together in this file as well. Then here we need to analyze in I think we can add this content at the end of that content. That will be proper addition. Here I can add this after. What this tool will do, will it add it at the end of that? It looks like it will add it at the end of that block. And now here I am comparing numbers of lines. This is smallest number, so this block of code starts earlier than anything else in these files. Then if I look approximately on the numbers, as far as I can tell, maybe this is done as well. And then this file, I think I can add this. I think I overwrote something. Duplicate lines here, and then this block of code should be before that. maybe this is done as well. So when this is done, I can do double check like git diff tool -d for entire directory. I will check on what I'm doing here. I'm opening diff tool, which is configured to be meld in my case, and I'm comparing last commit from version control system to what I have in my workspace here. So I see differences. I git diff here in not so easy way to understand, but I open these differences between last commit and my workspace in this comparison tool. And what I want to check here is that I have not lost anything, I have just added content here, because if I mistakenly overwrote something, it may happen that I actually deleted some blocks of content here if I made mistake. Because in this case, superset of this merging means take everything together as much as possible, so nothing should be lost. Everything should be added if there are some unique blocks of content or code. In this case it's content. And as far as I can tell, it looks like I have not deleted anything, but I have added missing parts. So what now? Now I have solved particular conflicts with these separate files catb 1, 2, 3, 4, 5. But I need to create new file called just catb where everything is put together. And how can I do this? I can open some editor. Like Eclipse or whatever, and I can do copy and paste inside this editor 5 times. But in this particular case I will not do this, because I don't like to do copy paste 5 times. If these files are nicely formatted, and they should be, that there are nice line breaks here at the end of these files, I can do following thing. In my main project U00, where I have these files, these are sorted alphabetically, and you should know there is command like show content of the file using cat command. But we can also say show content of files following this mask here. So star means placeholder, and it will replace to all files matching this particular expression. So then I see content of 5 files together, and so I can do following. Redirect this content into new file cat.txt. And I don't know about you, for me it's a little bit easier than copy paste 5 times. And now here we can review this file and we can see that there is overlapping content between these files, like Katb1 finishes with line 74 and Katb2 begins with line 74, and when I concatenated these overlapped. Actually, just for fun, what we can do here is when we concatenate them, we can sort in unique way for them, but unfortunately now it's sorted. But if numerical order, oh, that's proper way how to deal with these overlapping lines. Let's double check. Sort. Yeah. So, because lines are nicely or numbered by increasing numbers, if I have some overlaps here between these files, I can filter them out with sort command, show only unique lines, and sort by numbers, not by alphabetical order. And then redirect it to katb.txt file. And with that, I think we shouldn't have these duplicate overlapping lines from different files anymore. And if I have merged these conflicts correctly, then if I run JUnit test in test folder and activity 18, maybe it will even pass. And it passes, so that means I merged it correctly and I got entire content here as well. What now? As soon as you have done this merging, these two other projects, copies of these projects in Workspace, they did what they needed to do, and you can safely remove them. You have to have your development environment as clean as possible. When I worked as a professional tester, one of stupidest mistakes what I could do is to test something on wrong project, on wrong branch, on wrong copy of the project or whatever. And besides names, of course these projects are very similar, but they are different. Similar enough to get you confused, that you mix them together, different enough to get wrong results when you check something. And therefore my recommendation is that when you have done with this, clean it up. Probability will less that you will make some mistakes in wrong environment. And unit test checks only katb.txt, but we can add everything here as well. And so that is what is required in this particular activity. Do you have any questions or comments on that?